Hey, CL Prep, Guided Notes 3.3. And here we're going to learn about it's kind of the proofy part of dealing with parallel lines and their angles. So let's get started. So, so what we learned in 3.2, and this was like over a class ago, was that if the lines are parallel, so if you have a situation with two parallel lines, then you know that in that situation that the corresponding angles have to be congruent. And I just picked the most common ones there. So the important thing here is that we had to know the lines were parallel first. And once you knew that, then you could say that those angles were congruent, like I've marked them. And what we learned in the exploration was kind of the backwards of this, right? We learned that, so if I give you a situation with two corresponding angles that are congruent, then you have to know based on that, that's going to tell you in that situation, same situation, that's going to tell you that the lines have to be parallel. Yeah? So, so the original statement, what we saw up here, and the converse are both true statements. And so I wrote them up above there as two conditional statements, you know, the regular one and then the converse where we switch it around. But we can actually combine these into one statement called a biconditional statement. And this is how you write it. You could say corresponding angles are equal and then say if and only if the lines are parallel. So what that means is if you have an if and only if statement like that, it means that it's telling you that the statement works as is and the converse also is true. So if you know corresponding angles are equal, then you know the lines are parallel. And if you know the lines are parallel, then corresponding angles are equal. That's what a biconditional statement is, as opposed to our normal if-then statements, our normal conditional statements, where we don't know if the converse is true. You know, sometimes it is, sometimes it isn't. But if you write it with the if and only if, that's saying this is biconditional. These two things are locked together. If one is true, the other one is true, and vice versa. These things are inseparable, the truth of those things. Okay? It's called a biconditional statement. You can recognize it by the if and only if, but don't just like oh, if and only if, it's biconditional. Make sure you have this idea that the original and the converse are both true at the same time. Okay? So, we're going to prove an example of this. We already looked at corresponding in the exploration, so let's look at the alternate interior angles theorem. We already know that if the lines are parallel, then alternate interior angles are congruent. We already got that. Now, let's try to do the way back, which we haven't proven yet, so that's why I put a dotted line there. Like, is it going to be true? I mean, I just told you it is, but we want to find out, like, okay, if you knew the alternate and interior angles were congruent, then would you know the lines had to be parallel? And that's what we're going to prove right now. So, so here we go. It says proof, the second part of the alternate. Okay, got it. So given those two angles are congruent, prove the lines are parallel. So what I want you to notice here is I want you to notice that we don't know yet that the lines are parallel. So we can't use any of those other congruent or supplementary things. We can't use corresponding. We can't use alternate exterior. We can't use any of that because we don't know the lines are parallel yet. So I don't know that angle 1 is congruent to angle 2, except for the fact that they gave it to me. So here we go. Let's go with this proof. So 1, they tell me that angle 1 is congruent to angle 2. And that was given. Yeah. Now, the only way I can show lines are parallel at this point right now is that we've got the corresponding angles. We showed that the corresponding angles converse worked, that if corresponding angles are congruent, then the lines are parallel. So I just need to show that some corresponding angles are congruent, and then I'll know that the lines are parallel. We need another angle in here, so we have corresponding ones. Let's go with this one. So remember, you can always add a label something that you want to work with, even if it's not labeled in the drawing. So I'm going to mark angle 3 there and say, well, then I know angle 1 has to be congruent to angle 3, and that's vertical angles. So 1 is congruent with 2, and 1 is also congruent with 3. That means angle 2 is congruent to angle 3. And you could give it a substitution or transitive I would accept. So now this is a key thing. We've shown now that this angle is congruent with this one. And based on that exploration that we did, and I reiterated it right here, that if you know corresponding angles are congruent, then you know the lines have to be parallel. So I can say, oop, those are corresponding angles, and they're congruent. I've already shown that. Therefore, I better label the lines just so I can say it easier. A has to be parallel to B by the corresponding angles theorem. It's not the converse. I mean, it is the converse, excuse me. It is the converse. But remember, we're just going to call it the corresponding angles theorem. And we're going to say that the corresponding angles theorem is the if and only if statement. And so you can use it for both directions. The book will always separate it. They'll say, sometimes they'll use corresponding angles theorem. Sometimes they'll use the converse, and they'll write converse in the statements. We're just going to say the corresponding angles theorem works for both. And so we're renaming it and naming it differently than the book does to make our lives easier. So what do we have? We were just given that alternate interior angles were congruent. And from that, we were able to prove that the lines have to be parallel. Remember, the key thing here when doing these proofs is you have to know, are the lines parallel? So in the beginning, you want to look and say, have they told me the lines are parallel or not? Because if they have, then we've got all those theorems. We got the alternate interior, we got the alternate exterior, we got all those relationships of things being congruent and some things being supplementary. So check to see if the lines are parallel, and if not, you can't use those theorems to prove the angles are congruent. So notice, like in this one, I never used a parallel theorem all the way through this. I used vertical angles, I used the given, I used substitution. I never used a parallel line theorem. I never said angle 2 is congruent to angle 3 because of corresponding angles, because I didn't know that the lines were parallel yet. Once I knew the lines were parallel, then if I had to do some more stuff, now I could say all kinds of things. Now I can use all those theorems because I've proven in step 4, I proved the lines are parallel. It's like, oh, the lines are parallel. That changes everything. Now we know a lot of stuff. Okay, so just make sure when you're starting a problem, say, do I know the lines are parallel yet? Because if they are parallel, then I can use all those theorems. If they're not, I have to wait until I've shown that they're parallel. And so we could do this for all the other ones. We could prove the alternate exterior. We could prove the consecutive interior converse. We could prove any of those to show that it works both ways. We're not going to do that here. We might do that in class as a little activity next time. But these are the theorems then. So remember, the book does it one directional. The book says if the lines are parallel, then, and you have all these different relationships. Right? But we're going to do it a little differently. Erase, 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 erase. I guess I should have done undo. We're going to say the lines are parallel if and only if the corresponding angles are congruent. And what that means is, if you know the lines are parallel, then you know the corresponding angles are congruent. And if you know the corresponding angles are congruent, then you know the lines are parallel. We're saying this goes both directions because we're writing it as a biconditional statement. And the name for that is just the corresponding angles theorem. So if you want to go either direction, you can use the corresponding angles theorem. And same thing with alternate interior angles. If the lines are parallel, then the alternate interior angles are congruent. If the alternate interior angles are congruent, then the lines are parallel. And that's called the alternate interior angles theorem. Number 3, the lines are parallel if the angles are congruent. If the angles are congruent, the lines are parallel. If the lines are parallel, then the alternate exterior angles are congruent. That'll be called the alternate exterior angles theorem. And because we've written it this way, it gives us both directions. We don't have to have one name for when the lines are parallel and a different name for when you're trying to show that the lines are parallel. We'll just call it one name. And finally, if the lines are parallel, if and only if consecutive interior angles are congruent. Okay, were you guys paying attention? I made that mistake intentionally. Remember, they're not all congruent. This is the one that is different, and consecutive interiors are supplementary. Now, if I'm not trying to say, ha ha ha, I knew that and you didn't. If you thought, oh, they're congruent, that's fine, and you didn't catch that mistake, totally fine. But I just want the reason I did that was so that like, ooh, I gotta, like, if you didn't notice it, and you're like, oh yeah, consecutive interiors, those are congruent, then I wanted you to kind of be aware of that and go, oh, I missed that, huh? Okay, I got to make sure I pay attention to that because that's something I can miss. So I'm not trying to make you feel bad. I'm trying to make you feel like better prepared because you know what some of the tempting mistakes are that are out there. And so that theorem, the biconditional for consecutive interiors, is just going to be called, of course, the consecutive interior angle theorem. Okay, THM for theorem. Mathematicians, we like to abbreviate. Okay, we're going to show you one more example in just a second, but I think I'll stop the first video right there. And so we'll show one example of just kind of getting started on being able to do these things. Okay? And I'm going to stop this video. But one more, it'll be pretty short.